Namaskar friends, welcome to this lecture number 12 on our course on product design and development. As you are aware that we have already finished our discussion for 2 weeks, and the broad topics that we have covered in those 2 weeks were on the basic concepts of product design and development, the product life cycle, the product design steps, the value engineering concepts we have covered in week 2, and then we have seen the fast diagramming approach, which is very well known approach for the functional analysis of a product. We have also seen the functional cost relationship matrix and the functional cost relationship methodology to improve the design of the product. Now we are into the week 3 of our discussion on product design, and we are discussing the various design tools which can help us to make a good design. In our lecture 1, that is overall lecture number 11 and lecture number 1 for week 3, we have discussed one of the important aspects of product design and development, that is house of quality, in which we have seen that how the voice of customers can be related to the technical requirements, and we have tried to understand it with the help of a pizza selection company or a selection of a pizza company. We have seen that how the voice of customers or the customers requirements, needs and responses can be mapped to the technical requirements with the help of a relationship matrix. We have also seen that there is a relative importance column or room in the house of quality, which helps us to, we can say, differentiate or categorize the various requirements of the customer. And house of quality, the output can be that we can use the information available or information derived from the house of quality for benchmarking our performance with the performance of the other companies. We took an example of a pizza company. There can be number of other examples where house of quality has been used, and there can be slight modifications in the various rooms of the house of quality. For example, the house of quality that we have seen was not having any complaints room. There can be a complaints room also in the house of quality. Moreover, we did not feature much on the goals and objectives of that company in our example, which was kept as it is only. So there can be additions or we can say modifications in the various rooms of house of quality, but some of the rooms will definitely remain the same, that is the voice of customers, the relative importance of the various, we can say, requirements of the customer, the technical requirements matrix, the relationship matrix between the voice of customers and the technical requirement matrix, then the correlation matrix showing the interrelationship among the various technical requirements. So all these are the common rooms in any house of quality issue or problem. You will see all these rooms existing, and the information available is mapped using these rooms, and then the decisions are taken based on the house of quality, the overall picture of the house of quality, the overall output of the house of quality. So with house of quality we can maybe compare our product, we can even find out that which technical requirement has to be given more importance and which technical requirement is not much influencing the customer's needs and requirement and can be left out or can be eliminated. So it has got practical implications also. It's not just a theoretical tool which can be used, but it is a practical tool which can be applied scientifically for understanding about the product design process. Now let us go to the next stage of the product design. We know that what are the technical requirements that have to be met, what is the requirement of the customers, what do they want. Now we have to design the product, and for designing the product we have to make a model of the product, because usually we say graphics or engineering drawing is the language of engineers. So we need to understand that how we can put whatever is the requirement of the product on a piece of paper, and how the product would look like, what would be the various parts of the product, how these parts would interact with each other, how they will be assembled to each other. So we have to explode the product into its individual parts and components, and then these parts have to be designed individually, and then they have to be combined together to make a complete product. Now we have to understand that whatever decisions, whatever information we have taken out from the house of quality, or what are the technical specifications or requirements required to, or maybe important to meet the voice of customers, now we have to work on those technical specifications or requirements in order to design the product successfully. And for that purpose in mind, computer aided design is an important tool, and we will try to see that what this term means and how it will be helpful to us for designing our product. Moreover, we will see that what are the important softwares which are useful for computer aided design process. So let us go one by one and try to understand that what are the various aspects of computer aided design. Now here, this is the first slide. You can see a very rough sketch, or maybe we can say one of the basic or primitive ways of representing information. Here it is written CAD, which is the simplest way of representing any piece of information. Here you can see another component here. So this is the way the products would be, you can say, designed using the CAD tool. So in CAD, it is computer aided design, but it is not only the design, it starts from the drafting or maybe sketching to final engineering drawing to some part of analysis, and we can integrate our designs with the analysis tools also, and it can be a complete package which can provide us engineering solutions. So we will try to understand that what is the basic fundamental behind this term, that is computer aided design. Now let us see, try to understand the definition of computer aided design. So computer aided design is a use of a wide range of computer based tools. So I have already told in the previous slide that it is not just one tool or one software which you can use and design. It is a combination of tools depending upon our requirement, and then we will see in the subsequent slide that how these tools can be combined together to finally make a product or to design a product. So it is a wide range of computer based tools that assist the engineers, architects and other design professionals in their design activities. So computer aided design is not only one software, but it is a combination of software which combined together in order to assist the engineers, architects and other design professionals in their various activities of product design and development. Now let us see various CAD tools. Where do they fit in? This red triangle represents the, you can say, intersection of the various concepts, that is the definition of CAD tools based on the constituents. So there may be softwares which may only be good at computer graphic concepts only. Maybe only you can design something, maybe different tools are there, you can just do the sketching on the screen and then you can save it for further use, but no analysis can be done based on that sketch. So maybe you have simple computer graphic concepts, then you can have a geometric modeling where you can do some dimensioning and a drawing can be made, and then there can be analysis tools. Maybe you give the density of the material and you give the size and shape of the material. You can compare that which material should be used in order to make a lighter product, the geometry remaining same, the dimensions remaining same, only the material is changing. Now we have to see that we want to design a lightweight material or lightweight product, so which material should be chosen in order to make it light, or it is easy once you know the density, there is no need to do the analysis. But in many cases it may be a multi material concept in which the complete product is made up of maybe 5 or 6 different materials. So there, if you give the input of the material for each and every part of the product and then compare the two maybe concepts, that in one particular product you have 6 different materials, in other product you have 4 different materials and their densities are different of the material, and you want to compare which one would be heavier, which one would be lighter. So that type of simple analysis can also be done. So there would be CAD tools, they fit in here, this triangle. So they will have the graphics facilities also, geometric modeling facilities also, as well as little bit of analysis. So there would be standard softwares which may not be having a very high analytical capability in order to solve your engineering problems. Some of the softwares may only be limited to drafting of the problem into an engineering drawing, but we will see that what can be the capabilities of the various CAD softwares, or what are the combination of tools which can be used to solve any problem using the concept of computer aided design. So here this is a very good slide to explain that where CAD tools usually fit in. So just to summarize, there are 3, you can say, edges. So as per the edges, it 3 important capabilities they possess. So one can be computer graphics, geometric modeling and analysis. So any good CAD software can be used for solving simple problems of maybe related to the weight reduction, or maybe sometimes related to the modification based on the shape and the design, or the you can say the size. So different things can be analyzed using the design tools. Sometimes we may also use the concept of finite element analysis, which will fit in here in the purple box here. So we have graphics, geometric modeling and analysis. We will see in the subsequent slides that how CAD can help us to solve various problems. So computer aided design is used to draw the things. So this is the first part, that is sketching and the geometric modeling. So we are not talking of the analysis right now, but we will come to analysis also, that CAD can be integrated with the analysis softwares also, or analysis softwares are now being inbuilt into the CAD softwares to solve simpler problems also. So computer aided design is used to draw things, very basic definition of CAD. CAD design software is used in many industries, including automobile industry, aerospace industry, medical devices, defense, plastic injection molding, just the tip of the iceberg. CAD can be used in almost all engineering industry. This is just the list of the major users of CAD softwares or CAD applications. So if you wish to join an automobile or aerospace company, you should know the fundamentals of CAD. Not only the theoretical fundamentals of CAD, you should know how to apply the concepts using the various software platform. So you should know hands-on training you can have, or you can learn on your own the different softwares which help you to design a particular part, or at least to model a particular part using the various options available on that platform. We will try to understand maybe the fundamentals of those also. Now we are here comparing the conventional design process and the computer aided design process. So you can see in the conventional design process, what are the various steps? You can see recognition of need, problem definition, synthesis, analysis and optimization, evaluation and presentation. Standard approach already discussed in our week 1, where we have seen the product design process. Now in computer aided design, we have geometric modeling, engineering analysis, design review and evaluation and automated drafting. So you can see the computer aided design process is slightly different from the conventional design process, and this we will try to understand each one of these steps one by one. So once you know, maybe from the house of quality you have found out that what are the technical requirements which have to be met in order to meet the customer requirements or the voice of customers. Now we are working on those technical requirements and trying to design a product around those technical requirements, and for that we need to first model the geometry of the product. So this is what is outlined as the computer aided design process, or what are the various steps involved in the computer aided design process. So right here we have all the information related to what actually we want to design, and based on that design we will follow these steps and come up with a design which is now ready for prototyping and manufacturing. Now first part here is the geometric modeling. Now in geometric modeling you can see, in computer aided design, geometric modeling is concerned with the computer compatible mathematical description of the geometry of an object. Now some of you may be wondering, who are not from engineering background, that how data is saved on our system. Usually we see a picture, it is a square, there can be a circle inside. So how this square and circle is stored in the memory of the computer. So there it is saved as the mathematical description of that square and the circle. So that CADs on geometric modeling, it computer compatible mathematical description of the geometry of the object is saved inside the system, that is inside the computer. The mathematical description allows the image of the object to be displayed and manipulated on the graphics terminal through signals from the CPU of the CAD system. Now we can display, we can manipulate, we can work on that, we can cut a section, we can make a hole inside a geometry. If it is a 3D geometry, we can extrude a hole out of it, or maybe we can add certain features on the geometry. So all that is done. We see on the screen the actual geometrical translations, but in the back end or in the software these are all mathematical operators which operate, or there is a mathematical description to each and every shape that we produce on the screen. So that is the representation, true representation of those things is not in the form of a square which will be saved in the memory of the computer. It will be the mathematical representation of that circle which will be saved in the memory of the computer. Maybe there may be 2 words only written for that circle. On your screen you will see a circle, but in the memory you may have only the central coordinates of that circle as well as the radius or the diameter of that circle. So in your CPU you are storing 2 pieces of information, that is the radius and the center of the circle, but on your screen you get a complete display of the circle. So that is the relationship between how the geometry is modeled on your screen. So you should know what is happening at the back end of the system. So geometric modeling is nothing but it is the representation of your data on the screen. If you want to model a square, it may ask you that give the center and the radius, and it will generate that circle on the screen, but at the back end it will be stored as the radius and the center points only, or center coordinates. So first part is geometric modeling. So if I want to solve any problem or a structural problem, I want to see the impact strength of a table, maybe the table on which we are placing our books and computer and laptop. I want to see how much impact it can take. So first part of the design of the table would be I have to represent it on my computer screen. It can be a 2D model or a 3D model, and once I model it I have to give what is the length, what is the width, what is the thickness of the ply, what is the steel frame that is used to support that table. So all that will fall under the geometric modeling stage only. Then the next stage is engineering analysis. So first part is representing our problem on the piece of the on our screen or on a piece of paper, but in computer aided design it is paperless. We will model everything on our screen. So first is representation of the geometry on the screen, and that is called as the geometric modeling. In next stage we have the engineering analysis. In engineering analysis, in the formulation of any engineering design project, different types of analysis is required. Now just two important types of analysis I am trying to explain here. First one is the analysis of the mass properties. It provides properties of a solid object being analyzed, such as the surface area, weight, volume, center of gravity and movement of inertia. Now I have told you that the softwares these days are not only the drafting softwares that you can make a geometry on the screen, but they have the analyzing or analytical capabilities also. So we can analyze maybe a particular thing based on our requirement. So maybe we can compare the weight of the various designs, we can compare the surface area of the various designs. The software will give us the output that what is the surface area of this particular design. Now suppose we want to compare, as we know that the heat transfer is a function of the surface area, and we want to design a particular surface in order to minimize the heat transfer from that surface. So we will see we may have 4 or 5 designs. Now we should know that which design has the minimum surface area, so that the heat transfer is minimum from that product or from that object. So the CAD software will help us to compare the surface area. That surface area is minimum for a particular design. So we will take that design. Why? Because the heat transfer from that design, that particular design will be less. So these days many CAD softwares have got the analysis capability also, and one of the analysis can be the analysis of the mass property. Another can be the finite element analysis, where we will discretize the product into the very small elements, and then we can apply the boundary conditions on those elements or on that geometry and see the behavior of that geometry. We can see what are the types of stresses being developed, what are the strains being developed, what are the displacements happening. So all that we can do on finite element analysis. With this technique, the object is divided into large number of finite elements which form an interconnecting network of concentrated nodes. So it is only showing that we can divide the complete structure into its individual components or smaller finite elements, and then apply the boundary conditions. For example, we want to solve a cantilever beam problem. We can model that thing, divide that beam into the individual components, apply a load here and see how it will deflect, what would be the maximum displacement that is happening, or what are the type of stresses being developed on the application of load. So those type of problems can be solved using the finite element analysis, everything on your computer screen. So CAD these days is not only related to drafting, but it can be, we can say, combined with the analysis procedures also, and can give us a complete design of the you can say product. Then the third stage is the design review and evaluation, which means checking the accuracy of the design. It can be accomplished conveniently on the graphics terminal. So we can do the design evaluation. Then the automated drafting. Automated drafting involves the creation of a hard copy engineering drawings directly from the CAD database. Now whatever we have designed successfully, as we can see, as I have already told, that maybe we may have 4 or 5 designs and we want to select a design which has a minimum surface area. So we can do the execution of our program and see that which particular design is giving us the minimum surface area. That design now we have selected, and we can do the drafting for that design with all dimensions and all details, and we can even generate a hard copy for the onward transmission to the prototyping department, where they can start manufacturing the prototype of that product using any of the standard prototyping techniques. From our discussion point of view, we would be focusing on the rapid prototyping tool as one of the tools for prototyping our designs or models. So last part in CAD would be automated drafting, in which we will be passing on the information or the finalized information to the next stage. Now this is a generic CAD process you can see, taken from OCW, Open Courseware for MIT EDU. So here you can see you have an engineering sketch, maybe a rough sketch of a product that you want to make, maybe a rough design of your mouse that you operate with, the mouse with which you operate your cursor on the screen. So if you can have a rough sketch of that mouse, what can be the next stage? Then you start, you put all your settings, units, grids, whatever. Maybe units can be whether you are going to use the absolute unit, you are going to use centimeters or millimeters or what, all those units and grid, all that will be set here. Then you have to see whether you are going to 3-dimensional or 2-dimensional model. If you are going to use 3-dimensional model, you can see this may be a cube, cylinder, hole inside a square. So there will be, this is maybe out by these two, you can see you can generate a third geometry. There is a solid cube here, there is a cylinder here, cylinder from cube, you subtract this cylinder, you get this shape. So if you are working in 3D, this type of operations you can do. You have a solid thing, this is a thing you want to remove from this thing, this is the final product that you get. So this type of modeling you can do in 3D. From 2D point of view, you can create lines, radii, part contours, chamfers like this. You can add cutouts and holes like this. So you can do a 2-dimensional CAD modeling, you can do a 3-dimensional CAD modeling in which you can generate 3-dimensional volumetric shapes. So then you can do the annotations, maybe changes, and then you can do the final dimensioning, length, breadth, width, centimeter, millimeter, kilometer, whatever dimensioning is required, verification of that drawing, and it can go to the output. And output can be a CAD file or a drawing which can have extension of DXF, or it can be IGES files. IGES files is usually used as a interface with the other analysis softwares and can be used as an input for the analysis softwares like the finite element method. So you have IGES files output also coming from the CAD process. So in CAD process we may have we may choose a 2-dimensional modeling process, we may choose a 3-dimensional modeling process, and accordingly we can use simple operations like this in order to get our final shape. This is our final shape in 3-dimensional modeling, this is in 2-dimensional. So we can make different types of shapes. This is just the representational shapes. Whatever shapes that you want to make, you can make. There are a number of operations which can help you to get the exact shape of the product that you want to make. And here you can see there is a command given, extrude, rotate. So you can use these commands in any standard CAD software to generate the exact shape of the product that you are trying to design. So this has CAD has got a lot of capabilities these days and is a very helpful tool for the designers. Now let us conclude that what can be the advantages of using the CAD. First is to increase the productivity of the designer. So it has completely revolutionized the process of design. So we can see that using a screen very easily, if you develop an expertise maybe on one software, you will be able to make all the standard shapes and sizes, even the non-standard shapes and sizes very easily. So it improves your productivity as a designer. Create concept design of a product, better visualization, as we can rotate the views, we can change the views, we can have different views from different angles. So display in several colors to appeal the customers, display or inner details of the assembly. So we can have cut section views also in case of CAD, that is one thing. Reduction in the design cost, editing or refining the model to improve the aesthetics, ergonomics and performance. So whatever design we have made, we can analyze it from the ergonomics point of view, we can analyze it from the aesthetics, different color combinations can be tried. We can also, sometimes performance may not be totally functional or totally possible, but in many cases we can try to analyze the performance also based on the CAD models that we develop. So it improves our productivity, it improves the quality of designs, it can use of analysis of tools such as FEM, analysis tools. As I have already discussed, you can do FE analysis based on the CAD model, stress analysis, vibration analysis, computational fluid dynamics, thermal analysis, fluid analysis can be done very easily. So we can integrate our CAD model with the analysis software and do a complete analysis of the product. Greater accuracy in design calculations and reduction in error. So human intervention is there, but since it is system based and auto correction features are also there in many design software, so the chances of error gets minimized and the design calculations are more or less accurate. And we can study the product from various aspects such as material requirements, cost, value engineering, manufacturing processes, standardization, simplification. So there are number of advantages of using the CAD software, and if you compare it from a manual design being developed by a draftsman, which is a design representation, only a drafted information on a piece of paper. Here we can integrate our draft or the geometric model with other number of other softwares and come out with a complete design of the product. So it has got lot of advantages. That quality of design also is better because it has been analyzed not only from one point of view, maybe from different points of view, or the design philosophy in totality can be implemented using the softwares. To improve the communication, yes, because many times I may be using, although many standards exist or numerous standards exist for the engineering drawings, but sometimes there may be a slight modification here and there by a person who may be using some non-standard procedure. So in that case, in case of CAD, that is not possible. It leads to better visualization, greater legibility, standardization of design, drafting, documentation procedure, because it is software based. Similar type of output would come out, and which has to be interpreted by the other you can say people of the team also in the similar manner, because it is standard approach. So use of design data for analysis, drafting and documentation, process planning, tool and fixture design, manufacturing inspection. So whatever standard output that we generate out of a CAD software can be used as a data for the subsequent operations of product design and development. So this is the last slide for today. Major CAD software products are AutoCAD, ProEngineer, SolidWorks, CATIA, Unigraphics, Ideas, and there are number of other companies also which are these days developing the CAD softwares. So in summary, CAD is a very good technique or very important technique for product designers, and since in our course we have to discuss this topic of product design and development for 10 hours only, it is not possible to have a complete tutorial on any standard CAD software, but I would advise each of the learners to at least register for any company training or in your college, wherever possible. Try to learn at least one or two CAD softwares. List is there, you can even add to this list, you can append this list, whatever software available, you can just start working on the screen. Just try to click various icons on the screen and try to design some products based on the computer aided design philosophy, because it is going to be the most important, we can say, step in the overall product design process. So we can have the concept, we can model the concept, maybe rough sketch, but final output has to be very technical in nature. It has to be very specific in nature, and in order to generate that specific output for the next stages of the design process, we need to have knowledge of the CAD software. So I would advise each one of you to learn at least one good CAD software for the product design process. In our next class, we will try to learn another tools which are very helpful for the product design process. Thank you.